Hello everyone, welcome back again to the course Comprehensive Slope Stability Analysis using PLAXIS 2D. This is tutorial number 20 and generating a slope stability report in PLAXIS 2D. So in this lecture I will show you how can we generate or create a report in PLAXIS 2D after the analysis. So I will create a report from lesson 19, influence of benching on slope stability using PLAXIS 2D. So this is from a previous lecture. The factor of safety was 1.509, and I click on view calculation results. And after that we can create a report in file menu. We click on file, and in here we have a report generator, so I click on it, and in here we have two options: separate data file or PDF or RTF format file. So I will select the PDF format file, and here I can set the location that my report will be installed in, and I click on next. So in here we have the option to create the report, for example, for all faces or only one face or two face. So for example, in this example I will try to create a report for all faces. Maybe sometime we only need a report at one face only. After that, after we select the faces, we click on next, and in here we can select or choose the data which we want to be included in the report, or we can select all, so all of these data will be included in the report. But I don't recommend this one because there are many data in here which we have not used or we will not need it in the report. That's why we will select none, and we will select the important data for our report in here. So first of all, we have in here we have a connectivity plot or input nodes plot. We don't need it. Table of input nodes, we don't need it. Fixity plot, we want that the fixities type be shown in the report. And after that we have active loads plot. So when you see this one, this is a picture will be included in the report, but in here the table shape, so the table will be included in the report. And after that we have table of active point load. We don't have any point load. And table of active line load. We will not we don't want this table in the report because in here we have active loads plot, so we want it in a graphical form. And in here also we have table of prescribed displacement, which we don't have. Table of water loads, we don't need it. And also we have a cluster plot, it's not necessary. In here we have volume information, we don't need it again. We have the material plot. For example, in this tutorial we had only one material, and it will show us on the graph. For example, if we have this one is useful when we have more than one materials. For example, when we have 2, 3 or a number of soil layers. After that, this is important material information. We want it to be included in the report. And in here we don't have anchors or table of drains, etc. And interface, also general project information, we will need it. And calculation information, we will select this one as well. And we don't need calculation information per phase. So after that we click on next, and in here we have deformation with next and export. So right now the reports will be generated, and in here we have number of images, 48 images will be created. in this report, and I will show you how the report will be right now. So it is generating the report now. So we click on generate, and because I already generated the report with the same name, so I can override it. So I can open the report now, and in here we have the first page. It's written PLAXIS report and the name of the tutorial. So maybe you have a different tutorial title, or the title of the project you work on. And in here we have calculation results, first initial phase, and it shows us the fixity plot in initial phase. As we can see, we have a fixed support in here, and roller supports in these two sides, and it shows us also a fixed plot in all phases. This is a factor of safety phase, and so this is important because maybe in an advanced project the fixity will not be the same at all phases. That's why PLAXIS gives us in all phases. In here we have active loads. In initial phase we don't have active load, only we have a self weight of the soil. In surcharge load phase we have this surcharge load, and also in safety factor phase we have this surcharge load as well. So in here we have a material plot. So as you can see, it's written number 1 because we have only one material defined in this tutorial, and for this phase also, and the safety analysis has been used. And in here also we can check the safety analysis is performed using strength reduction factor and strength reduction method, and this is a strength reduction factor, and the safety factor is 1.509. Also in here we have a total displacement in initial phase, as we can see, and total displacement in surcharge load phase, and total displacement in safety analysis phase. So we have total displacement in X, similar, and also we have, for example, incremental deviatrix trend in initial phase, in surcharge load phase, in here in the safety analysis phase, and also we have a deformed mesh in initial phase, in the second phase, surcharge load, and also in safety analysis. And we have active pore pressure. So we can see the active pore pressure is 0 in all phases, and we have a Cartesian effective stress in X direction and in Y direction as well. Also we have total Cartesian strain. And in here we have a plastic point history or plastic point failure in initial phase. We can see we have some plastic failure point in surcharge load phase, and also in factor of safety phase. And again we have a plastic point in here. As you can see, this plastic point, actually this is important in the report. In here this plastic point failure shows the failure surface of the slope. This is the quality of the mesh we can see in initial phase. This is a generated mesh, and in other phases as well.